How we can solve the threesome problem today. It's a very popular problem, and I've seen this question getting asked in Amazon interviews, Facebook interviews, and pretty much even in HP and Goldman Sachs. I've had this question asked to me in a lot of interviews. It's a medium difficulty problem, and I feel like the medium difficulty level is justified for this problem. Let's see how we can solve this problem. First, we need to understand what the problem statement is. It's a variant of two-sum problem. We are given an array of numbers. Numbers can contain duplicate values, they can have negative values, positive values, or zeros. We need to find all possible triplets such that their sum should be equal to 0, and these triplet values, the indexes of these triplet values should not be same, they should be different. In this situation, adding -1, -2 and 2 will give us 0, while the index of all these values are different. Similarly, we need to calculate all possible triplets whose sum will give us the value 0, and we need to ensure that we cannot add the same element twice. All the index have to be different. That is the required problem statement. Now, whenever we have duplicate values and we need to traverse the array with duplicate values, the first thing to think is to sort the array. That will help make our lives much more easier. So our first step is to sort the array. Let's sort this array, which is in an ascending order. nums.sort For anyone that doesn't know this step, solving this way in JavaScript will ensure that we always get the right values. So this is a pretty standard way of sorting the values in ascending order wherever required. If you want to sort it in a descending order, you'll just do b minus a. But before this, we need to check for a base case sort of situation, which we can consider it as step 0. That is a situation where the values of the array are less than 3 in length. If the array length is less than 3, we'll just return the array as is. There will be no possible triplets in those situations. So we just need to check for that condition. If nums.length is less than 3, we'll just return nums as is. And then once we have the array sorted, we need to loop throughout the array length -2, because we need to find triplets. If we are considering I, after I there should be 2 more values for it to be a triplet. So we'll be looping from 0 till length -2. When we are looping through the array, first we will check if the value at I is greater than 0. We need to know that we have sorted the array, so all the values are in ascending order, and when we loop through the array, if the first value itself is greater than 0, then all the values that follows it will also be greater than 0. So there is no possibility that we can have a triplet whose sum could be equal to 0. So in this situation, we just break the loop, and we need an output array to store our triplets, which is what we will be returning from our program. Right. So if the nums I is greater than 0, we'll just break. Then if it's not the first element in the array, that is if I is greater than 0 and the value at I is same as the value at I -1, in this situation, we'll just skip the iteration because we need to avoid duplicates. In other situation, what we do is we need to have two indexes, index pointers. We have I. Now we need to set, if this is our I, we will set our start point to the value just after I and right pointer towards the end of the array. And for all these values, we'll see if we could, for this value, and this value, we'll see if that can form a triplet. Otherwise, for this value, we'll change the I or the j depending on certain condition, and we'll keep on checking if the triplets will sum up to 0. So let's see, our start value is not 0, it's I plus 1. It's the value after I, and our right pointer is nums.length minus 1. It's at the last element. And for each of these situations, while start is less than right, here we will not add start is less than or equal to right because these are indexes and we have discussed that the index values cannot be same. So start less than right, while this condition is true, we'll calculate the sum, which is nums of I plus nums of start plus nums of right. This is our sum. If this sum is equal to 0, then this is our ideal condition, in which case we will push the triplets nums of I, comma, nums of start, comma, nums of right. We'll push this. Else if our sum is less than 0, if the sum is array is sorted, and if our sum is less than 0, we need to move our value towards the higher value. So we will increment our start pointer in this situation. Otherwise, the sum is greater than 0, so we will just decrement our right pointer so that we can move towards 0. That is our goal. In this situation, once we have pushed our triplet values, now we need to increment our start value and decrement our right value because this triplet has been covered. I, start and right is covered, so we just incremented our start and decremented our right to get the new triplet values. Once we have decremented, we need to check for condition where we can encounter duplicate values. We need to ensure that we are not affecting the original check condition, that we need to ensure that the start is still less than right, and if that condition is valid but nums at the new start value is same as nums at the start minus 1, in which case we just increment because it's a duplicate value. Similarly, while ensuring this condition, if nums at right is same as nums at right plus 1, in that situation we will decrement our right value because that is also duplicate. We need to avoid duplicates. Once that is done, we have our program in place. I think this should give us the right value. Let's see. It's passing the initial conditions. Let's submit and try. It passes and it's just taking 148 milliseconds. This is a good condition to have. Some people will write this condition again and again inside every if statement that will, but having it calculated beforehand and using that variable will avoid multiple processing. This is like very minute optimization, but when we are solving this problem for a big time companies, everything matters. The time complexity here is the sorting will take n log n time complexity. We will iterate this array for n iterations, and inside this while condition, all these operations are happening in big of one time, so this will not add to the time complexity subsequently. So O of n log n plus n is just equal to n log n. So this is our time complexity. And our space complexity, usually we will not consider the value or the array that is getting returned as the output. So that is not considered in most of the situation. The interviewers will ask you to ignore that. But if you do consider the output array, then that would be O of n. This is our space complexity. That is it for today. Let me know if you like this video. Please share, subscribe, and also let me know in the comment section if you want me to change the way in which I explain the problem, or if you want me to solve a different problem, or if you didn't understand anything in the way that I explained this problem, just let me know. Or if you found any mistakes in my explanation, also please kindly let me know. If there are any better solutions to better ways to solve this problem, even in that situation, please do let me know. Thank you.